This video is on how to create an exponential function that goes through 2 points. So the general equation for an exponential function looks like this, where you have your f of x, or basically your y, is equal to some number times your ratio with the x in the exponent. So this is your general exponential form. This a of 0 is your y value when x equals 0. Or, if you want to think about it, it's just your f of 0. This r right here is your ratio, or how much you multiply to get the next number. All right, so let's do an example of creating an exponential function. Let's say we have this table right here. So let's say we have this table where when x equals 0, your f of x is 20. When x equals 1, your f of x is 80, etc. And right down here is your general formula for an exponential function. So this a of 0, like we were saying before, is when x equals 0, what is your y value, or what is your f of 0? So right here, this number, this is equal to your a of 0. Your r, or your ratio, is what number will you multiply in order to get the next number in your sequence. So this is times 4, times 4, times 4. So therefore your r is equal to 4. So the exponential function, or exponential equation, that passes through these points is f of x is equal to 20 multiplied by your r, which is 4, with x in your exponent. All right, so pause this video, take notes when you're ready, hit the play button. Let's do another example, but with fewer points. So let's say you're asked to create an exponential equation that goes through the points 2, 63 and 4, 567. Quick reminder, when you have, these are coordinates right here, and that is the first number is your x value, the second number is your y value, and your y is like your f of x. So let's put our points into our table. So when x is equal to 2, my y is 63. So x equals 2, my y is 63. When x equals 4, my y is 567. All right. So what I know here, so this is the information we know. And we now need to create an exponential function that goes through these 2 points. What I know is I'm missing a few different values here. I'm missing this one, and this one in my table right now. But what I know is that from here to here, to go from this value to this value, I would multiply times r. From here to here, I would multiply times r. And at each time, it would be the exact same number r. So let's create an equation using this. I know that if I have 63 and I multiply times r and then multiply times r again, so if I have 63 and I go multiply times r, I would get 563. So let's write that equation. If I have 63 and I multiply times r, I would get 567. Let's make the colors match. Okay, so we have here an equation, and we have one variable, r. So you can just, at this point, solve for r. So first thing I think I'm going to do here is I'm going to simplify this right here. 63 times r is 63r squared. Okay, I have here r squared multiply times 63. So in order to get rid of times 63 from this side, I'm going to divide both sides of my equal sign by 63. On the left side, 63r squared divided by 63 just becomes 1r squared, or just r squared. My 567 divided by 63 equals 9. All right, so now I need to get rid of this squared. The inverse or opposite of squared is square root. So if I square root both these sides, this has two solutions. You have r equals square root of 9, or r equals negative square root of 9. Your r value is not going to be the negative one because it wouldn't be exponential if your r was negative. So we know that this particular one is not your r because it's not going to be negative, or your r is not going to be negative. So this is your r. Your r is equal to square root of 9, which is r equals 3. All right. So we know that this is your r is equal to 3. Wonderful. Now all we need to do is find this value right here in order to have the equation, or in order to create the exponential equation for this. If if going in this direction is going to be times 3 times 3. Going in the opposite direction will be divide 3, divide 3. So 63, divide 3, divide 3 will get you this one. Your 63 divide 3 will get you this one right here. This is going to be 21. If I do 21 divided by 3, it will get you this one, which is 7. So this value right up here is 7. If another way we could have done that, if you did not want to think about it that way, you could have also created an equation. We know that this box right here that's this box right here. We know that that box right there times r will equal 63. So that box, multiply it times r will equal 63. And we know here that your r is 3. So this is times 3 times 3 will equal 69. So therefore, this box times 9 is equal to 63. To get rid of times 9 from this side, I'm going to divide each side by 9. So your box is equal to 7. Just a different way of getting this 7. Both are fine. So your equation for the exponential function that goes through 2, 63 and 4, 567 is f of x is equal to 7 multiplied by 3 exponent x. All right. Pause this. Write down any notes you want. Hit play when you're ready. Let's do one more example here. Let's create an exponential equation that goes through 1, 7 and 4, 28. Once again here, you are missing a few different values. We're missing this one, which we need for our exponential equation. We're missing this one and this one. I know to go from this value to this value, I'm going to go times r. And it'll be the same times r to go between each one of the functions, each one of the numbers in our sequence. So to go from 7 to 28, 7 multiply r, multiply r, multiply r will get you 28. So let's create that equation right there. 7 multiply r, multiply r, multiply r will equal 28. And now let's solve for r. 7 times r times r times r is 7r to the third power. Let's solve for r, since this is r to the third power multiply 7. To get rid of that multiply 7, I'm going to divide by 7, divide by 7. R to the third power equals 4. 28 divided by 7 is 4. Right? To get rid of this 3, we're going to do the inverse of the third power. Inverse of third power is the third root, or cube root. The cube root of r to the third power, these two 3's will basically go away since they're inverses, and all you'll have left on the left is an r, and this you cannot really simplify. So your r is equal to the third root of 4. Now let's solve for that one right there. I know that this box, multiply times r, will get you 7. Let's write that equation. And I know that this r right here is equal to this r was equal to third root of 4. Okay, so let's solve for this box. Since this is times third root of 4, divide both sides by your third root of 4. So your box is equal to 7 divided by your third root of 4. If you got this far, you can technically create a exponential function that goes through 1, 7 and 4, 28. You have f of x is equal to this very first value. And this very first value, when x is equal to 0, is 7 divided by your third root of 4. Times your r value, which is the third root of 4. The exponent is x. Now, in math, they don't like having roots at the bottom of a fraction. So, if you wanted to get rid of this root on the bottom of the fraction, here's the way you do it. So I know here that the third root of 4, you can write that as the third root of 2 times 2. And if I had 3 2's inside here, then I can get rid of this cube root. So I'm going to multiply the top and the bottom by the third root of 2. Multiplying by this does not change the value of this blue part because I am just multiplying by the number 1. This right here is a fancy way of writing the number 1. Okay. So now here you have the top is 7 times third root of 2. The bottom is third root of 2 times 2 times 2. Which is just equal to 2. the bottom. So the top is third root of 2, bottom 7 times third root of 2, the bottom is 2. So if you wanted to write our equation in the way math people like to, which is no roots at the bottom, then instead of 7 divided by third root of 4, you would write 7 times the third root of 2 over 2. These two brown right here are equal to each other. So the most proper way to write that equation looks like this. So this would be the equation right here that goes through 1, 7 and 4, 28 and is exponential.